second part of 8.6. Now we're getting into solving log equations. We're going to learn three different methods. And the first of these methods, we're going to use the property of equality. Now this is familiar because in the property of equality, it comes from the fact that if the bases are the same, the exponents are equal. And we learned that when we did problems like, if we had 3 to the 4x power, and that equaled 3 to the 8th power, when the bases were equal, the exponents were equal. So this is referring to that. That's where it comes from. Here, the bases are equal. Therefore, this part is equal to this part. So we pull them out, we set them equal, and we solve. So let's use this property of equality to solve our first equation. Now remember, we want to write it as a single log on this side equals a single log on the other side, and then we can pull out the parts to solve for x. So this side is done. We have log base 5 of x, so that's nice. No combining to do. Here, on the other side, I need to combine all this into a single log base 5. So I have two things to take care of. I have this adding part, and then I'll take care of the 2. Now PEMDAS still applies. I still need to do the part here in parentheses first. So I'm going to leave the 2 alone, and let's combine log base 5 of 5 plus log base 5 of 6. And don't tell me this is log base 5 of 11, because you are not adding. In logs, when you're adding, you're really multiplying them. So this becomes log base 5 of 30. And now I need to take this exponent. I'll rewrite this side. Equals log base 5 of 30 squared. And 30 squared, I think that's 900, if I can do my math right. Now I have it as a single log base 5 and a single log base 5. So now I can pull out this part and this part and set them equal to each other. So in this case, there's really no solving to do. X is equal to 900. All right, in this next example, we have work to do on both sides. We need to write both sides as a single logarithm. So working on this part first, let's take this 3 and bounce it up and make it an exponent on the 10. So I have log base 2. 10 to the third would be 1,000. So I'm going to write it as 1,000 minus log base 2 of x. So if we want to finish this side, since we're subtracting here, to write them as a single log would be division. So I could write this as log base 2 of 1,000 over x. Alright, so we have that one side done into a single logarithm. Now let's concentrate on this other side. Okay, I apologize. There's a typing mistake on my Word document. This 1/2 is not supposed to be here, so I'm going to cross it off and then continue. So I'm sorry about that. So here, the only thing I have to do to write this as a single logarithm is to take this 1/2 and bring it up as an exponent. And if you recall, 25 to the 1/2 power means that we have 25 and we're taking the square root of it. 1/2 power means square root. And of course, the square root of 25 is 5. So now I have both sides written as a single logarithm. Now I can pull out this part and pull out this part and set them equal to each other. So I have 1,000 over x equals 5. And we may have forgotten how to solve these when the x is down in the denominator. Two methods come to mind depending on your preference. Some people think of this as multiplying by x on both sides, which is fine because x divided by x, it gets it out of the denominator, and then I have 1,000 equals 5x, and I can divide both sides by 5 and get 200. Another method I see students using right here, they will take the reciprocal of both sides. So they would end up with x over 1,000 equals 1/5, and then you can just multiply both sides by 1,000 and you'd still get 200. Either way, it's a skill we need to review, how to solve when the x is in the denominator. All right, in this next example, we're going to have to refer to the graph of the logarithm, which is why I drew this off to the right here. So we'll solve this one, and then I'll show you why I'm referring to this graph. This is from our notes from the last section. So here on this example, we have a 2 that needs to come up and become an exponent on this parenthesis. Just keep that x plus 3 together. So we have log base b of the parentheses x plus 3, and this is being squared, equals log base b of 36. So now I have these both as single logs. They are the same base, so I can pull out the parts and set them equal. So I have x plus 3 squared equals 36. And hopefully you recognize this as a quadratic. We will be finding two answers, so we need to have all those skills ready to go from the quadratic chapter. Here I would not recommend foiling it out. The square root method would work better here. So if you take the square root of both sides, the square root here would be x plus 3, and the square root of 36 is plus minus 6. So use the plus minus now to get our two answers. So we have x plus 3 equals positive 6. Subtract a 3 from both sides, and one answer is 3. And then x plus 3 equals negative 6. Subtracting a 3 from both sides, we get x is negative 9. Now we have to look very carefully at these answers because one of them is a problem. This is why I drew this graph over to the right of the log function, log base b of x, because we need to realize that this function does not exist over here in negative land. Try doing it on your calculator. Try entering, let's say, log base, whatever you want, log base 3 of negative 9. Your calc will give you an error message. The log does not exist over here where x would be a negative number. So it exists over here just fine at a positive 3. We'd have a decimal number. So therefore this answer needs to be rejected because it does not fall in the domain of the log function. So what I would recommend adding to your notes, we need to realize that our answers to logarithm equations must be positive. So we could just write, like I said, adding somewhere in your notes, that the domain of any log function, the domain of the log is positive. The answers would have to always be positive or they don't exist. And if you ever have a question and you're not sure, you can enter it in your calculator and it will confirm this.